This week's episodes were brought to you by the generous support of Eric Sumner. Hey you folks, Quilly18 here, and welcome to another episode of our Unity tutorial, where we are making the Royal Game of Ur, a very simple board game here in Unity, in a tutorial that is hopefully well suited to beginners, and then we're going to follow that up with a much more complicated topic where we try to create an artificial intelligence to play this game competitively against players. I mean, not that it's a terribly complicated game, but there is going to be a surprising amount of strategy in here once we get going. It's not that luck-based. Again, it's going to be a lot like a backgammon or something. Anywho, we are at the point here where we can, in fact, roll the dice and click on one of our pieces and advance it. But it just teleports instantly, so we're going to go ahead and throw some animation in there. Still not, the full game logic. I mean, it gets to the end of the path, which is, so you go this way, that way, and then over here, and then you leave the board and you quote-unquote score. We have a note in here, but we don't actually do anything. Ultimately, scoring, it's not a point system. You're just trying to get rid of all of your stones here. And we're not alternating between turns, and, we're not checking to make sure that there's not two pieces on the same tile. We're going to do that very, very soon. But first, we want to animate it. So what I want to do for the animation is, Leslie, instead of teleporting directly to the location, what I want to do when we go through here, because what we're doing is we are looping we know how many spaces we're supposed to move. Then what we're going to do is we're sort of looping through our list of legal moves to find out what our ultimate final tile is. And then here we're just teleporting to it. But instead what we're going to do is we're going to load up a queue of tiles to move through. Well, you know what? Let me back up there. We are going to do that, but that's not what I'm going to do as the first step. Instead, what I'm going to do is I'm going to have us have a smooth move from our current position to our goal position. That's what we're going to start off as. And to do that, we need to track what our target position is going to be. So we track our location with vector 3s. So we're going to want a target position. And we're going to want to keep track of that. And in our update, we're going to, as a start, we'll just make sure, it should already be the case, but we're going to set our target position to be this.transform.position. Just make sure we're in the right place, and that's going to be okay. And we're going to make use of our smooth damp function to figure out where we want to get to. Smooth damp is a great function. There's a bunch of different variants of smooth damp. I think, is there smooth damp? Yeah, there's smooth damp in the math function, which will go from one floating point number to another. But we're going to use the one in vector 3. So smooth damp is a function that takes your current position and your target position and a certain amount of time. Your smooth time is the amount of time you want to take to reach your ultimate target position. And it also needs a sort of bookkeeping variable, which is this current velocity, which you don't set yourself. The function internally deals with that. It uses sort of a spring function to smoothly move you from one location to another. As opposed to a linear move, the smooth location will it'll start a little slow and then speed up and then slow as you get there. And it makes it look very cool and very sexy. And that's what we're looking for. So our current position, hey, we got that. That's just this.transform.position. That's our current position. What's our target? Well, it's this target position that we haven't set to anything yet, but I've got a variable for it. Okay, we're going to do that. Then it needs this reference vector 3 current velocity. What's the deal with it? Well, again, this is a bookkeeping variable that this function will use. We don't have to mess with it, but we do have to provide it with something to store the info in there. So we need to make a vector 3 that we'll call it'll just call it velocity or something. That's totally okay. It should start at 0 by default. You can force it, again, it's sometimes it's nice to force these things to be a certain thing just to you explicitly know. This is going to start at 0. Anyway, we have to pass in, position. We have to pass in this velocity vector as a reference. And the reason for that is that, normally when you pass, because a vector 3 is a value number or something like that, you'd be passing a copy of this velocity vector. By passing it as a reference, you're letting the function actually change what this variable is on the fly without having to use a return value or anything like that. It's not terribly important to know the internal details as long as you pass it in this way. And then finally, we have to pass it the smooth time. So this is the time you're supposed to take to reach the total target. And, you know, so small number will go very fast. So how long should it take? Let's have a float here called smooth time. We'll set it to, let's set it to a half a second. You know what? Actually, I'm going to set it to 1 second, so it should be nice and slow for our first one, and then almost certainly we'll want to tune that down. So we're going to pass that in. Now, it does allow a few other optional variables, like maximum speed and whatever, but we're not going to need that in here. So we're going to pass this there. If we set a target position, so by default, this will basically just set idle. But what we can do is do a little check, like not even bother calling it. Something like if transform.position is not equal target position, then we do this, or you know, we can have some other bookkeeping variable or something just in case it matters. I'm betting it does its own checks inside, but we'll do that. Now, this does return a value, and this value is what our new current position should be. So our new current position is going to be the return value from this. Okay, just like that. What I'm going to do is I'm going to set up a little helper function here, which is something like set new target position, which is going to take in a vector 3. And all it's going to do is it's going to set target position to be equal to pause, and it's going to reset the velocity to be equal to 0. Which, again, we don't really need to stress about that. Let's get rid of that, because it is going to be important to reset this when we start the new target move. So what's going to happen way over here, instead of teleporting to the location, we're not going to teleport to it. We are going to set it at our new target position. Let's see what that does. It's not going to do the right, like, it's not going to do our ideal behavior, but it's going to do something kind of funky cool. So we're going to roll the dice. So with a value of 2, this is going to be the tile we get to. So if I click here, this will now smoothly move there. Now cut through things, but it smoothly got there. If we click it again, it'll slide over to the next one. It takes a full second to complete this move, which is probably a little bit on the long side, but I want to properly showcase it. I suspect we probably want like quarter seconds, honestly. Something like that. I think we're going to want it to be quite speedy in the end. Let's get a 2 again. There. See, there you go. You're not feeling like you're waiting as it slides along here. Now, I would like, see, here it moves it diagonally, and here again it moves directly there. Especially, let's get a big value. Let's actually, hold on. I want to get like a 1, get you here, and then I want to roll 4. You know what? Oops. Roll. There we go, 4. If I click on this guy, he is going to move directly to here. Is that what we want, or would we want him to like sort of swoosh around the whole thing? I kind of feel like the swooshing around the whole thing might be cool. I also, obviously, am not very keen on the fact that it slices through the terrain over there. So what I'm going to propose is this. When we click on a tile to move it, I propose the tile lifts itself up to be just above the height of the board over here, including if we click on here. It goes high enough to be above the base line of the board, then moves one tile, another one, really shows you the whole path. We want it to do that quite quickly, but I would like to see the entire process. I think that would be quite cool. So how do we do that? Well, what we're going to need to know is we're going to need to know the entire sequence of all the tiles to move through. And the thing is, we sort of do that. This is processing through the entire sequence of all the tiles to move through. It's doing that right now just to find the final tile, but we could save the entire list along the way, which is kind of interesting, right? Instead of just like banking it like this, let's do something like this. So let's set up a vector 3 No, I want an array of tiles. An array of tiles. This is the move queue. Okay? And what this is going to do, over here, we know that our move queue is going to be an array which is going to be sized based on spaces to move. All right? So it's going to be 0, 1, 2, 3, or 4. There we go. Tile. Spaces to move. 0, 1, 2, 3, or 4. Really, I think if you try to set this as a size 0, it will just kind of go bonkers. So we probably should at this point just, if spaces to move is equal to 0, we should probably just return, because it like really doesn't make any sense to process anything else. So we'll just bail out if that's the case. So we set up a queue. So now it'll be, this will be an array of 1 to 4 things. And what's going to happen here is we keep incrementing final tile as we go through. But what I want to do is set move queue I to be equal to final tile as it works through this entire process of tiles. So this will be an array of tile, a tile, another tile, and another tile, with that last tile being our true final tile in the end. We moved off board tile by 0. Yeah, we shouldn't even get here. This should actually never, ever be a thing. We can remove this because we are now bailing out early again if we get a move of 0. So it should never be a case. So the actual animation can take part now. So what we want to do now is we'll probably still set current tile to be equal to final tile, but we're not going to set the new target position right away. Instead, we're going to do something like, so we have our move queue, and then maybe a move queue index, which we're going to start at something like -1. Or, you know what, like a big number. That's actually going to be fine. Clearly much bigger than this will ever be. And then our update logic is going to be a little bit different. If our transform position is not at a target position, then we move there. Else, so we have reached our last desired position. Do we have another move in our queue? Question mark. So what we do is something like this. If move queue index is less than the move queue dot length, then what we do is we set new target position based on the move queue at move queue index. And then we increase the move queue index by 1, like that. There you go. So if the move queue index is less than the length, then we grab this current thing that's in our queue and increase our index. And we set that as a new target position. And therefore, on the next loop, we're going to start moving there. Let's do that. So what we need to do over here is we have to set move queue index back to 0. That will tell us that it's safe to go and start working on this once more. So we still don't have the vertical stuff, but what this should do is cycle through a series of things. Let's see if we've got everything reset properly. Oh, well, first of all, we've got error. Oh, dot transform dot position. You don't want a tile, you want a position. Okay, we're getting some errors. Oh, right. We aren't checking to see if move queue is a legit thing, which won't be at the start of the program. If move queue is not equal to null and the move queue index is less than that. There we go. So it actually doesn't matter what this number gets set to, because we can check the nullness here as a sanity check. There we go. That makes me feel a lot better. Okay, no more errors. We're going to roll and a 2. I'm going to click this. It's going to go there. And then there! Hooray! It does take a little longer to move to the next one. I guess because it's very, very, very slowly achieving its position. Because it slows down, right? And then it's going incredibly slowly as part of its goal to reach its position. So instead of this, instead of checking to see if we're exactly at the target position, what I'm going to do is something like this. Vector3.distance. If the distance between our current position and the target position is less than a very tiny number, 0.01f. So 1/100th of a unity world space. Oh, less than. If it's less than, no. if this is greater than this. If this distance between these two is larger than this, then keep moving towards it. Otherwise, we're going to figure that we're basically there. So let's try that again. Roll. Let's get a bigger number. Oops. Oh, there we go. That looked a little bit better. Come on. Give it a 4. There we go. Click on this one. 1, 2, 3, 4. Love it. I feel that pace is very good. So you can tune this. Let's go and move this. Where it says smooth time, let's go and smooth distance equals this. So if you make this a slightly bigger number, it'll take a little bit less time between gaps to like complete some of this stuff. Yeah, that's going to be okay. I'm actually wondering about inverting this logic. I am, in fact, going to do this. I'm going to say, if this distance is less than smooth distance, then what we're going to do is we are going to set a new target. And I'm not even going to bother with an else here. We're just going to keep trying to move over here. Because then it will always keep trying to move to like hit the exact perfect position eventually. And this should work. And this should also remove a 1 frame delay in our movement. Let's verify that this works, but I think we're going to be okay. Let's roll and get a nice big number. There we go. 3 is pretty good. Yeah, looking good. And if we move you again and move you guys and get everything sort of like, ah! If we do double click, it gets a little weird, which makes sense. Oh, and when you score, it still gets removed right away, which we want to adjust because... Yeah, right here. We reach the end and must score. We actually don't want to destroy ourselves. Instead... How do you want to do this? Let's say we can set final tile to be equal to null in this case, but then that will lead to funky stuff here. So as I say, load a bunch of nulls in there, and then when we sort through this, if it's a null is the next thing in queue, then we know we're good to go. Sorry for the brain delay here. I guess we could have put a flag in something like remove me. I mean, there's a bunch of different things we can change. I'm trying to figure out like the smoothest and least like silly way to do this. I guess I'll put in a flag. Bool score me equals false. Something like that. And then what we can do is we can set final tile to null. So we can say if final tile is null and score me is equal to false, then that means we need to do the starting tile thing. I'm a little leery about these special flags, but we'll see. Score me is equal to true. Final tile is equal to null. So if we end up in a situation here where, because this could be a null, tile next tile is equal to this, and that if next tile is equal to null, then probably it's a score me at that point, actually. We are probably being scored. Really, nothing else should do it. We could check the score me, but I'm trying to... I feel like I can come up with a better way of doing this that's a little clearer. So this way we set our position based on the next tile. Here, what we do is we slide ourselves like way off screen. Set new target position. This.transform.position plus something like vector3.right times 100. We'll just pull it off the screen to the right. really quickly as our target position. And then when it reaches this, we actually want to remove the tile from the game. Well, I mean, if it's not visible, it's sort of kind of removed from the game. We actually, you know what? Rather than have this, we probably want to have like a little scoring pile. Yeah, that's probably it to do. Move us to the scored pile. We just don't have that worked out yet. But probably what we want is a little pile of the white and black stones over here that have been scored. Yeah, right now I'm just going to move it here, just 10 tiles off to the right. So let's try this and see if we've caught all the cases. Go ahead and roll 3. So we got you. Yeah, because of the double clicking, you wouldn't really be able to click it a second time before it finishes, but it sort of like rapidly teleports to the end there. So if I click this, it'll go there, then here, and then it should whoop off to the side. Ideally, it's going to go to a pile. Okay, next thing I want to do is I actually want to have it not clip through the territory, and I want it raise up a little bit, because it's entirely possible for... if I click here, they're going to pass through each other, and I'd like to feel like they go over one another. So I want to change the logic a little bit over here with this. Instead of just moving directly to the target, I want to do a little thing. We want to rise up before we move sideways. So... if this .transform.position.y is less than float smooth height 0.5f. So half a unit upwards is what our target is. So if our y is less than the smooth height, we want to move up first. We'll have to do a case for going down, but this is going to do the up first. And then we'll put an else. And we'll need some... We almost want set target position to be a little different. Because we're going to need to reset the acceleration between. Okay, well, okay. Okay, I think I've got it. I'm trying to make this look cool. Okay, so if we're less than the target height, minus smooth distance. There we go. Then we've got our current position. Our target position is actually going to be this position plus vector3 dot up times smooth height. So our target position is not exactly this, actually. That is incorrect because it'll always be too high. It's going to be a new vector3 with the x set to this.transform.position, the y being exactly set to smooth height, and the z being this.transform.position, z.x. There we go. So we're trying to target the same x and y, but the height. We're going to try to go upwards first. If we've already reached the right upwardness, then we're going to go sideways. Although in this case, again, it's going to be a new vector with the target position dot x, target position dot y, and still this height. So what it'll do is right now it should hover over our final destination. Let's see how that looks and feels. So I'm going to roll. Right. We only want to go up if we're not at our target position. Let me move this to a function first of all. Advance, move, Q. Boom. Okay. Move that out. We won't run it right now. So we've kind of got three states. This is we've reached the target. How's our height? If this.transform.position.y is greater than smooth distance. Okay, because here what we're trying to do is go down. And if our height is still too high, then we want to move downwards. And our downwardsness is going to be bringing us to a height of 0. Else, right position, right height. Let's advance the Q. So we're going to call advance move Q here. And then we can put an else if here. So if we're in the right place, we may have to drop down or we may have to advance the Q. If we're not in the right place, then we continue. Then we check, hey, are we too low? Because we should go up first. And then finally, if we're not in the right place, but we're high enough, then we'll slide sideways. So what should happen here is these guys should stay on the goddamn ground. Thank you. We're going to roll the dice. I'm going to hit here. You should rise up, then go here, then hover forever. That's weird. So you've done this. The problem is it's not lowering. Because they're probably fighting each other. Right. We need to compare just the X and Y, X and Z components of the target position. Because this is never close enough. Because it's offset in the vertical. So what I need to do is set our, just zero out like the Y, like only compare so the new vector. I guess this can still be the target. Yeah. Target position like this. So if our current position 0, there we go. If our current position, assuming a y of 0, is in line with here, because that would be the same correct height, is less than this, then we know that we can start to drop or advance. Okay. This time for sure, except not for sure. Oh, come on! There you go. Target position, not Y. That's right, because here the target position is low. Okay, there you go. You don't float. I'm going to move to a 2. You go up. You go there. Right. We've reached our target. We only want to drop down if we're actually done the Q. If move Q index is less than move Q dot length and that. Move Q dot length minus 1, I think. So as long as we're not the last item in the list, or actually it's sorted the other way around. If move Q index is equal to this. So if this is the last thing in the list, then we want to start dropping. Okay. Ooh. Oh. If move Q is not equal to null, and there we go. Roll. There, then there. Not a -1? Oh, right, of course, because we incremented after, because it would be a thing. Yeah. Get a 3 again. There, down. And no up this time. And you're going to float over. Excellent. Now, I'm going to propose that the smooth time is going to be different for vertical. We're going to want to smooth it faster. I think I like this idea. Also, we got to reset the velocity in between, don't we? It seems to be working. I'm actually kind of surprised why that is. Maybe because it's a different direction. There you go. I think I like that. Good. Feels good. Could be the sort of thing we could speed up. Could be the thing, the sort of thing where we actually tweak the smoothing time based on how far we have to go. Like a quarter second might feel really good when you're just moving one step, but to have to like wait for each step when you're moving like 4 might feel a little tedious. So we might want to divide the smooth time down based on how many steps we have to go. So each sub-step goes a little bit faster. But that's, you know, I'll leave that as an exercise to you guys to tune that. This turned out to be quite a bit more funky and complicated than I'd wanted, and I still feel like there's a better way to do it, but it works. If it's stupid and it works, then it's not stupid. Although sometimes it makes for a bad tutorial. Okay, we've got that. Next thing I want to do is next turn we will introduce turn logic or player logic, so that after we move our one pawn, our turn is then over. So we can't move another one right away. We can't click on more things. It'll actually switch to like player 2 right away, reset all the dice rolls, and so on and so forth. Possibly after the animations are done, for example. But still, we want, even while something is animated, right? If I have this set to like a big number, if I can roll a big number like a 3, I don't want to be able to like click on the next one. So as soon as an animation starts, it's got to say, listen, you can't click on anything else that's, you know, that would be cheating. And then when all the animation's done, we flip over to player 2, giving that player a chance to roll the die and move, and then back and forth and back and forth. And then we deal with the fact that, hey, things aren't supposed to land on each other unless it's an enemy piece, in which case you can land on them, and then you bop them back to the start. Thanks for watching, folks. See you next time. Thank you to all the October patrons who make these videos possible, including these Mike Check supporters: Yoko Finn, Eric Sumner, Adam Keenan, Danny Welch, Tiburon, Mighty Mix, Pavel Zdanov, Michael McClintock, Aaron Tyson, Rorskal, Gurko Dries, TNSEE, Jasper Bisgard, Julien Gelafon, Marius Fieldvold, Speedy Savant, Steven Stager, Thomas Oberson, Jason Yanity, Stephen Bonnerman, Easter Egg Productions, and Neil Blakely Milner, as well as everyone who likes, favorites, and subscribes to these videos. Thank you very, very much.